students, in the last video I talked about converting time-based functions into the S domain using the Laplace transform in MATLAB. In that video we used the Laplace command in the MATLAB to convert the time domain function to the S domain. Now in this video we are going to discuss the inverse Laplace transform. Especially this helps us to convert functions back from S domain to the T domain. Throughout this session I will be using MATLAB commands to make this conversion process easier. Let's dive in together and understand how to apply these techniques in the area of control system. So in the previous lecture we used just Laplace command to transfer the T domain to the S domain, and here the inverse Laplace transform we use the command iLaplace. iLaplace means inverse Laplace. So in case of the Laplace we use the Laplace command, and in case of the inverse Laplace we use iLaplace, and then it will be the function in S domain. And these are the same command we already used in the previous sections, that is the sims s. So in the previous section the variables is t, but here the variable is the s, because we have to convert s domain to the t domain, and the previous case we convert t domain to s domain. So here we have to write the s and then rest of the same, but for the inverse Laplace you have to remember this command that the iLaplace means inverse Laplace. Here initially we take the basics example, that is the 2 by s cube, 1 by s square plus 1, 1 by s plus 1. You already know about this conversion. So 2 by s square t square, 1 by s square plus 1 is the sine t, 1 by s plus 1 e to the power minus t. Okay, so you have to remember when you are using 1 by s plus 1 a, so you have to remember the s is also variable and the a is the variable, so you have to define the variable as s as well as the a. Okay, and these are the MATLAB code. So here you can see the system sims s. So you have to write the function, that is the 2 by s cube, and just write the iLaplace of f, then you can easily find the answer, that is the output of, that is the t square. And next we take some difficult example. So here you can see this is just giving the partial fraction, but in second case you can say this is the normal case, just this is the transfer function. So in the MATLAB you don't have to convert to the partial fraction, just you write this function and just use the command that the iLaplace. Okay, and the third one the same one. In the next video, that third video, we use the MATLAB command to perform the partial fraction. Okay, so these are the answer. Let's go to the MATLAB. So this is the interface of the MATLAB. So first we will start the 2 by s cube functions. So let's start with the syms, and we have to define the variable, that is the s. Then we have to write the f equal to function. So first function is the 2 by s cube, 2 by s cube. This is the s cube. Then we have to write the iLaplace, L-A-P-L-A-C-E. So iLaplace and the f. Then just run this program, you will get the answer. Okay, so here you can see the Laplace inverse Laplace of 2 by s cube is the t square. Now if I changing the function, that is 1 by s square plus 1, s square plus 1, so its inverse Laplace will be the sine t. So here you can see this is the sine t. So now we take function s by s square plus 1, so it will be the cos t. So here you can see this is the cos t. Now if we take exponential, means 1 by s minus 1, then its inverse is e to the power t. Next we are taking f equal to 1 by s minus 1 s minus a. So you have to remember that you have to define the variable that is s a. Okay, so then you just run this program. Okay, so here you can get the answer is e to the power at. Now if you change the s plus 1, then it will be e to the power minus at. So here you can see e to the power minus at. Now we are taking the three different example. So these are the all are the normals example. Then we are trying to solve the difficult one, that is I already show you the three example. Okay, so let's start with same. So here I am taking only one variable, that is s. Then we have to write the function. So function f equal to, so first example is 1 by s plus 50. So 1 by s plus 50 minus s divided by a square plus 400. So a square plus 400, then 20 by a square plus 400, a square plus 400. Now we have to find its t domain, so we have to convert the s domain to the t domain. So just use command that is I Laplace and write the function that is the f. Okay, just checks 1 by s plus 20 minus s by, I am also take this bracket, s by a square plus 400 and 20 by a square plus 400. So basically this will be the e to the power minus 50t, and this is the cos function and this is the sine function. Okay, now so here you can see the answer is e to the power minus 50t minus this one is for the cos 20t and this is for the sine 20t. Okay, so this example is given as a partial fraction. Now takes the direct Laplace transform in the transfer function from. Okay, so next one is the f equal to s plus 4 divided by s into s minus 1 into s square plus 4. So I am writing this. So numerator is s plus 4 and the denominator is divided by s. So I am taking bracket here. S star means multiplication of s minus 1 multiplication of a square plus 4. So a square plus 4. Okay, now complete the bracket. So this is the numerator, that is the s plus 4, and this is the denominator. Just use the I Laplace transform and run this program. So here you can see, so it will be the e to the power t minus 0.5 sine 2t minus 1. Okay, so this is very simple example. So just use this command I Laplace in the MATLAB. You can easily find the transfer the s domain to the t domain. Now taking the last example, that is the 5s plus 2 divided by s plus 1 into s plus 2 whole square. Okay, just change the function. So numerator will be the 5s. 5s means 5 star s, star means multiplication of 5 with the s function plus 2, and this is the denominator will be the s plus 1 into multiplication of s plus 2 whole square, s plus 2 whole square. I am taking the extra bracket for the denominator portion and just run this program. You can easily get the answer. So here is the answer is the 3 e to the power minus 2t minus 3 e to the power minus t plus 8t e to the power minus 2t. Okay, so here these are the answer of the questions. So here you can see. So in case of the Laplace transform, just remember these things. So you have to first define the variable. In case of the Laplace, you have to define the variable as the t, and then you write the function and just take the Laplace transform of the function for the in case of the Laplace. But in case of the inverse Laplace, you have to remember two things. One thing that you have to define the variables as the s, and you have to change the command Laplace to I Laplace. I Laplace means inverse Laplace. Okay, so in the next video we talk about the partial fraction. So in the conventional way, it takes lots of time to convert one transfer function. It's then take the partial fraction, then we have to convert the inverse Laplace or Laplace transform. But in the MATLAB, we can easily find the partial fraction of any transfer function by using the Laplace command. So in the next video, we will take some example and try to find the partial fraction by using the MATLAB. Thank you.